This is the final assignment video for EPPL 519 from Paul Blossom. And what I'm doing is using Screen-O-Matic to create a class recording that describes how to create forecasts for a particular data set. Now, the data set here I have is the barley yields in England and Wales from 1884 to 1939. And I'm going to create two forecasts. First is a moving average, three-period moving average. And the way a three-period moving average is calculated is to average the previous three actual data points. And so that's simply done is equal to average. And then I just highlight those three, in this case from 1984, 5, and 86. Close parentheses and hit enter, and then I can drag that down, and copy all the way down here to the bottom. And in fact, I can go past the set of data points because the last one here for 1940 uses 39, 38, and 37 as the average. So that's a real forecast for 1940. We don't have any data for 1940, so I don't know how that turned out. The other one I want to do is a 5-period moving average. And this is very similar to the 3-period moving average, as you would expect. And so I'm going to calculate it just the same way, except we use the previous 5 periods rather than the previous 3 periods. And so I highlight those 5 periods just like that, hit enter, and there we go. Now I'm going to copy that all the way down and create the set of points for that. Now, the last one, the forecast, we can use, but there's no way to calculate the error. And you say, well, why do we need error? Well, we need to know which one of these is better. Otherwise, people say, well, I like 5-month or 5 period better than 3 period. No, I like the 3, but no one knows why. And so the idea here is to calculate an error metric for the forecasts. So I want to do one for both the 3-period and the 5-period. Now, when we can just calculate the error easily. I'm going to start here, so we have it for both of them, same length number of points for both of them. And if I want to calculate the error for the 5-period or 3-period, I'll just do it this way. I'll just use that. So that's the error for the 3-period. So this is just equal to the actual minus the forecast. And that's for 1 period. And so we can do the same thing here for the 5-period. And so this is equal to the actual minus the forecast for the 5-period. And we can copy those down, of course, like this. And so there we have those sets of errors. And you look down through there and you say, well, okay, there's lots of numbers and sometimes one's bigger than the other. And how do we know which is best? Well, there's so we could take an average. So I'll just put it here. This is the average error. I'll just use E for error. And so if I do that, so it equals average, and open in parentheses, just highlight the whole data column here, close parentheses, hit enter. Okay, so there we've got 0.1, and if I do highlight this, I get 0.1. So does that mean, so we ask, is it doing the right column? Yeah, it's doing the right column. We don't have any way to tell a difference between these two. And some of you will say, well, wait a minute. You're averaging negative and positive numbers together there, and the pluses are going to cancel out the minuses, and probably we want to know how far this thing is off rather than how see the pluses, because really you could be plus 10 minus 10 plus 10 minus 10 every time, be way off, and you'd have an average of 0. Well, okay, that's a fair criticism. And so what the mathematicians did was came up with this idea of the mean or the average absolute error, which means that we need to turn all of these numbers, all of the errors into positive. And the way we do that is through the absolute value function. So the mean absolute deviation. So I'm going to type that MAD. Well, I'm going to take the absolute of the errors here. E3. I'm going to create those first, and then we will calculate the mean absolute deviation. So this is ABS, E5. All right, so and the way we do that is easily enough, equals ABS for absolute, open in parentheses, type in the cell and hit enter. So you see that it turned the minus 0.2 into a plus 0.2. And if I do drag that over, it turned the minus 0.5 into a plus 0.5. So we're going to highlight both of those, drag them down to the bottom like we did before. And then I'm going to average those. So this is, and in fact, all I have to do, because I've created those numbers, just drag that across. And in this case, you can see that I got an absolute deviation of 1 for each one of the data sets. So there's no way to tell the difference between these two by the mean absolute deviation. So I should put MAD here, and these are the correct. I'll drag this down so that it's clear what those are. So here we have calculated not only an error metric, but the mean absolute deviation, and we can't tell the two forecasting things apart from that. Now you'd say, why would you choose one or the other? Well, the 3-period moving average responds more quickly to changes than the 5-period moving average does, and so you might choose it for that particular reason. You might do a more exhaustive search and see if there isn't one that comes in better than either 3 or 5. But that's how you do the moving average calculations, as well as creating the mean absolute deviation.